old and how stable is our solar system? On this question, astronomers have grown more uncertain year by year. The actual history of the planets could be a far cry from anything we learned in school. Here is our reporter Cameron Mercer with excerpts from his conversation with the electrical theorist Wal Thornhill.
We have always lived in a very interesting solar system. However, we have never been able to pin down just how interesting it is. First, it was entirely special, with no equal anywhere else. Then, a century ago, sentiment gradually shifted and people started to understand our solar system as a common occurrence. There were bound to be other solar systems out there, just like ours, waiting to be found. Less than 2 decades ago, we started making our first observations of other solar systems, and the more we find, the stranger ours seems to be.
The solar system has actually been described as weird when compared to planetary systems around nearby stars. We seem to have the gas giants much further away from the Sun than similar planets are around nearby stars. Around nearby stars, those giant planets orbit very closely to their star. And the answer to this problem is another ad hoc addition to the theory of how the solar system formed, and that is that the giant planets were not formed where we see them now. They must have migrated, because all of the exoplanets that we've discovered are large planets, even larger than Jupiter, orbiting their central star in days or even hours in some cases. So these systems of planets are quite different to anything that we see in our own solar system. This raises the issue of how exactly did our solar system form, and why are our gas giants so far from the Sun?
As straightforward a question as this seems, this is actually proven very difficult to answer. Astronomers quickly learned that the general theory of solar system formation couldn't work for our own solar system, since it postulates that planets form in more or less their current orbits. Uranus and Neptune are far out, too far out to have formed where they are today. So in 2005, some French astronomers came up with a brilliant idea. What if the planets' orbits could move? Maybe then they could migrate from some earlier state to the improbable arrangement we see now. This idea had been entirely untested until recently.
In 2005, Nature magazine published a paper which has become known as the Nice paper because it came from France. And that paper was trying to find the early states of the solar system and finding that nothing worked for Uranus and Neptune, the outermost gas giants. The gas giants simply couldn't have formed at a great distance because it takes far too much time for them to have accreted from a cloud of dust and gas. So the Nice model was proposed, which supposes the gas giants formed in close where they are more likely to form. Now this recent paper is the first simulation of the Nice model, and it's tried to simulate changes which could produce Uranus and Neptune at their present distances, and also Jupiter and Saturn in their present far-flung orbits from the Sun. The simulations of the Nice model show that Uranus and Neptune remain a problem. We still cannot make a planetary system that looks like our solar system, theoretically.
David Nesverny of the Colorado Southwest Research Institute ran over 6,000 simulations of the Nice model in his search for a viable early stage of the solar system. He had 4 target criteria that, if met, would qualify the simulation as a potential early state of the solar system.
In only 2.5% of cases were they able to satisfy just the first 2 criteria out of 4. This is a huge problem for the current theory of solar system formation. It means the early solar system could not have looked like it does now, with Neptune and Uranus in the outer reaches. The paper concludes with the formation of Uranus and Neptune, the outermost gas giants, and say that it's a long-standing problem in planetary science, and the paper finishes with future work will be needed to address these issues.
Astronomers are heading down the right path, starting first with a theory of static formation which hadn't the slightest hope of forming our system. They proceeded to then consider planetary migration. David Nesperny took this yet a step further and considered planetary ejection, in which case he found his chances of producing our current solar system increased almost tenfold over the Nice model.
It seemed certain that the solar system required rearrangement of the planets to explain their present placing and characteristics. The Nice model wasn't enough, just rearranging planets, so the next thing was ejection. But that also hasn't been enough. Did something more dramatic occur to produce the solar system we see today? In all of the theoretical work that has taken place, we have assumed that all of the matter that's in the solar system right now began there. No one, except in the very early days, considered capture of objects from beyond the solar system. There was a good reason for this. To do so, the object coming into the solar system has to lose energy, and gravity doesn't offer any simple way of doing that. In the electric universe, there is electrical exchange which can take place, and capture is very much more likely than it is in the gravitational model. So the very fact that we do have gas giants like Neptune and Uranus at distances from the Sun where they could not have accreted suggests that they were captured. Not only that, the motion of Pluto and some of the outer moons do suggest capture rather than having been formed in place.